Hi friends, we look at vectors. So under vectors, this is where we are told that a vector is a quantity that has both magnitude as well as direction. For example, if we talk of velocity, we talk of acceleration. Such quantities are known as vector quantities, because you can't have a velocity, which is the rate of speed against time. You can't have it without its direction. So there must be direction, okay, of that speed, which is against time. Then the other point is that a vector can be drawn as a directed line. So a vector can be drawn as a directed line. This is what we have here. It can be drawn as a directed line. Then the length of a line represents the magnitude of that vector, of a vector, and the arrow indicates its direction, where it is going. Okay, that is what we have. So if you are moving just around the same point, that one is not known as vector. It's not a vector quantity because there's no direction. There must be the size. We talk about the magnitude. The magnitude, we mean the size. Then the direction, we know the meaning of direction, where you are going. So we are told that the length of the line represents the magnitude. So what is the magnitude of this? It is from this point up to this point. And also the arrow, it shows the direction. Where is it going? It is going to the northeast. This one, it is moving from A to B. From A to B, not from B to A. So this vector, therefore this vector here can be written as A to B. The arrow on top shows the direction. Then it can also be written as the A and the bar, the small letter A and the bar, because this means that AB, it is represented by, or the unit of AB is A, small letter A and a bar. So what have we discovered so far under vectors? We are told that vector has got a direction, where it is coming from, where it is going. Where it is coming from, where it is going. Then you have to write the arrow on top to show that the direction is of this direction. So this is what we have. So a vector can also be written as a column vector in a form of x and a y. In a form of x, y. A vector can also be written as a column vector in a form of x, y. So where x, x is a value which is parallel to x-axis, and the y is a value which is parallel to y-axis. So that is what we have. So on the magnitude of a vector, we are told that it is the length of the vector. The magnitude of the vector, it is the length or the size of a vector. So the magnitude of a vector AB is written as, we put these bars and we write the AB and the arrow on top. This is the way it is written. Once you see this under vector, just know that that question is under the magnitude. Then if AB, this is vector, AB is equal to this, the column vector, therefore the magnitude of AB, it will be the root of x squared as well as the y squared. For example, if we say, let me just say e.g., if PQ, vector PQ is 86. Therefore, we are going to say the magnitude of the magnitude of PQ, which will be x squared plus y squared, where we are going to have what is our x squared. In this case, our x is 8 and our y is 6. So we write 80 squared plus 6 squared. What is our 8 squared? Or what is 8 squared? The answer is 64. So we have the square root of 64 plus 6 squared, 36. If we add the 2, we find that the answer will be 100. Now the root of 100, the answer is 10. So this is the magnitude of that vector. That will be the magnitude of that vector. That is what we have under the magnitude of the vector. Now, since we don't have the units there, you can just use the word units. Okay, that is the magnitude in those units, because we don't know if they are centimeters, they are meters, they are kilometers, we don't know. So from there, let's move to the next point where we have vector geometry.